So hello everyone, my name is Marina. I work at F6S alongside my colleague Luisa, and we welcome you today to this webinar, the AI Plan for You webinar, where we are going to talk about our open call tool for innovators. Today's webinar is focused on track A. And as for the agenda, we will have Andrea Micheli telling you about a bit an overview of the project and this specific open call with this specific track. Then we will have Alfonso Gerevini from the University of Brescia to walk you through the details of the track A for open call for innovators. And then my colleague Luisa will walk you through all the procedures, where you can apply, how you can apply, what do you need to fill in. She will show you how to do it. We will have 5 minutes by the end to answer some questions, but you are free to just write them in the chat during the webinar. We will answer them as we go, if there are any. And before handing the word to Andrea, I would just like to tell you that this is the first webinar because this open call features 3 different tracks, and today's webinar is focused on track A. But next week, 1 week from today, same hour, next Wednesday, we will have a second webinar focusing on tracks B and C, and we will present a couple of use cases that are engaged in this open call, so you see what tracks B and C are about. So if today is not the right fit for you, maybe join us next week. We will have different opportunities and more to talk about this open call inside of the same open call. Quick reminder that the open call closes by the 31st of January. So if you are interested, don't leave it to the last minute, just go ahead and apply. And with no further ado, I will stop sharing my screen, and I will hand the word to Andrea.
Yes, thank you so much, Marina. So let me share the.
You're muted,
You're muted.
Andrea.
Yeah. Still muted. Still.
Can you hear me now?
Yes. Yes.
Okay, good. I don't know why the button was disabled. So let me try to reshare the screen.
And you are muted again.
Can you hear me now?
Oh, yes, perfect.
Ah, okay. Apparently, when I share my screen, it automatically mutes itself. Okay. Every day you learn something. Okay. I was just saying that I'm going to give you in this presentation an overview of the project that is funding these open calls, and then enter a little bit more into the details of what is a planning engine. That is what we are asking in track A. So this is the list of the partners of the project. So I Plan for EU, as you probably know, is a Horizon 2020 project. So it is funded by the European Commission. It started in January 2021, and it will finish at the end of this year. So it's a 3-year project. And as you can see, we have quite some companies involved in the project that are bringing us use cases, and they're trying to apply planning technologies in their businesses, and some research institutions that are focused on planning. I will anyway enter a little bit more into the details in a moment. One of the key elements of the project, and this is a question that sometimes I get asked by people, is that one of the main motivation behind our project is that we have to contribute to this AI for Europe or AI for EU initiative, that is the European platform for AI on demand. The idea of this platform is an initiative, first of all, of the European Commission, and what they're trying to do is to create a platform that brings together AI stakeholders and AI resources from different, let's say, areas, different application domains throughout Europe, in order to somehow put all this knowledge and all these people working around AI, here AI is used in a very broad sense, in the same, let's say, pot, and try to accelerate innovation, try to create a one-stop shop for anybody who's looking around for AI knowledge or technology or services, and ultimately to essentially create and grow an AI market in Europe. So that's the ambition of the platform. And as you can see here, the AI ecosystem in Europe is quite broad, and there are a lot of investments. If you look, we are here in terms of projects. So we are an initiative funded under Horizon 2020. Together with us, there are other 5 projects that essentially are sister projects of our own that are working on different technologies and different, let's say, areas of AI. Instead, we focus on automated planning. So what is automated planning? In a nutshell, I saw some known names among the attendees, so probably you know, but in a very few words, essentially is a reasoning technique that, given a model of a system, here the word system is very general. Let's say it can be a robot, it can be a factory, it can be, let's say, a fleet of robots, so on. Some, let's say, thing that you would like to control, and that you know at least partially what is the behavior or the expected behavior of this system. So you have a model of this system, you have a goal that you would like to reach. So, for example, bring the robot in that specific location. What you would like to do is to find a course of action that we call a plan to drive the system from its current state to this desired goal, possibly respecting some requirements. So if you look in the picture, the ingredients are essentially 3. So you have the system specification, you have to know the initial configuration and the objective, and then the job of the planner is to automatically synthesize this plan or strategy. As we will see, there are different kinds of plans that you might want to generate, but yeah, from a very high level point of view, that's the job of the planner. There are different applications for this kind of technologies, moving from, let's say, robotics or automation. So, you know, essentially in that case, the system that you are trying to control is a machine, is a robot. And the ultimate aim here is to allow for flexible, robust, and cost-effective automation. Another example is to plan the activities in a factory. So you know what you have to produce at the end of the day. You know what the different machines, what the different workers are capable of, what are their limits, what are their working hours, and so on. And you would like to create a schedule, create a Gantt chart of the activities that needs to be carried out during a day in order to maximize the production and minimize the costs. Another interesting use case that we have within the project is to organize the agricultural practices in order to minimize the environmental impact. Again, here we have different machines, different actors who are contributing to these agricultural practices, and you want to orchestrate them in a way that they minimize the environmental impact. Again, the sort of the excuse or the main topic of the project is that I Plan for You would like to reinforce the AI for Europe platform by bringing planning as a first-class citizen. So what we are interested in is in creating demonstrators, finding use cases, creating technology or contributing technologies to the AI for Europe platform that all rotate around this concept of automated planning. We identified 6 innovation goals. I will be quick on this one. Let me show all of them here. The bottom line is that we would like to make planning more accessible for practitioners and innovators, and this means different things. So one is to create a simple way of expressing planning problem and integrating planning engines into other ICT technologies. We would like to make planning relevant in diverse application sectors. So in addition to the use cases that we have within the project, with one of our open calls, so with some of this cascade funding money, we actively looked for additional use cases in different application sectors to see what are the areas where planning can be relevant or can be used in principle. Again, we want to bring the planning technology into the AI for Europe platform. And then we also have the objective of creating some learning facilities or some documentation, some material that can be used for understanding what planning is and lowering the access barrier to planning technology. And then hopefully, given the use cases and the experiences that we are doing within the project, we would like to standardized or drive academic research towards interesting applications. So to identify challenges, identify loopholes or problems in the current technologies or in the current tools, and try to post those as challenges for the academic research. So as you can see, quite ambitious goals that we are trying to pursue. And the general vision that we adopted in the project and we are following is this one. So it's summarized in these infographics. The idea of this infographic is as following. So the core here, we call it the Unified Planning Framework. It is a reusable, planner agnostic Python. We decided to use Python as a programming language library that is offering an abstraction layer for the different planning engines. So the idea is that you can pose a planning problem at this level, so within the Unified Planning Framework, and then this planning engine, this planning problem can be manipulated, it can be printed, it can be devised within the Unified Planning Framework, and it can also be passed to a set of planning engines that can solve this planning problem and give back a solution, and the solution will be represented in a uniform way. So essentially, this acts as a sort of abstraction barrier that abstracts away the specificities of different planning engines, whether they use, a different modeling language or they have different characteristics. We are trying to sort of uniform them. The library is also capable of understanding what are the characteristics of the problem that you are posing, and so identify the subset of the planning engine that is capable of solving that specific problem. So somehow simplify the life of somebody wanting to use planning technology, and creating a platform that allows you to try different planning engines, try planning technology very cheaply, more or less what you could do, for example, with a neural network package like TensorFlow or PyTorch, right? You can try different algorithms, different architecture cheaply or relatively cheaply. We would like to do something similar for planning. I talked about planning engines, and in this presentation is super important to well understand what a planning engine is. So it's a general word in this sense. What I mean with that is that a planning engine could be a plan generator, so what we call actually a planner, so something like an IPC planner, fast downward or anything else. But it can also be something else that offers a service related to planning problems. So for example, a plan validator, or a visualization, or a grounder, or a simulator, something that is capable of plan repair, something like that, right? So the idea is to characterize the capabilities of what your planning engine can do, and try to create an abstract interface for that within the Unified Planning Framework, so that we can somehow group together planning engines that are capable of doing the same thing. And in order to do that one exactly, we created this notion of operation mode. So if in the documentation you see this word, it's essentially, you can read it as a sort of type of planning query. So one operation mode could be one-shot planning. So one-shot planning is, I have this planning problem, please think about it and then give me back a solution. So that's what more or less an IPC style planner will be capable of answering. Another kind of operation mode will be plan validation. So here's a problem, here's a plan, tell me whether it's valid or not, possibly if it's not valid, tell me why. Another example could be plan repair. So here is a problem, here is a plan, try to, this plan is not, is maybe not valid for this particular problem, so try to fix it and give me a valid plan that is similar, for some notion of similarity with respect to this plan that I'm giving you. And this engine declares which operation modes it supports. It can be more than one. And yeah, so essentially you characterize a planning engine by the set of operation modes and the type of problems, meaning the expressivity level of the problems that it can handle. For example, a certain planning engine can be capable of doing one-shot planning and plan repair for classical planning problem. So this is more or less what you can do. So far I talked about the blue part or the azure part of the picture. That is what is the part that is domain independent. So far we haven't talked about application domains or integrations or robots, nothing, right? So this is just pure planning in a way, in a very abstract sense. And instead, the orange part of the figure concerns more going towards the use cases. So try to integrate planning technology in different use cases. And so the API that is offered by the Unified Planning Framework, the idea is that it can be used to serve a collection of use cases. And we are doing that by what we call technology-specific bridges. So a technology-specific bridge is a reusable component, so a piece of software, let's say, that is using the Unified Planning Framework and is talking with some technology that is relevant for a use case. So examples, if you're doing robotics, maybe you are familiar with ROS, the robotic operating system. And so integrating planning capabilities inside of ROS by means of the UP, the Unified Planning Framework, is a piece of software that can be reused across different use cases or different robots. And so that is what we call technology-specific bridge. Another example could be warehouse management system. So you want to solve a logistics problem. And so what you do, you try to, you identify one family of warehouse management systems, you interface with their database, with their, let's say, formalization or modelization of the shelves, the packages, the orders, and so on and so forth. And you transform this data into planning problems, and you provide the capabilities of showing or using the plans generated by one of the engines. And so these pieces of code, these glue codes that somehow interface between the technologies used in the different application domains and the planning engine themselves are also part of the output of the project. So we identified, as you can see here, a number of use cases. For each of them, we will realize one or more technology-specific bridges. And in addition, that are the focus of the other two tracks of the open calls, so track B and track C, we are asking outside of the project and financing projects for developing demonstrators on other use cases and other technology-specific bridges that are relevant for people around Europe. Yes, I think I said everything. So zooming in a little bit more on what is this UPF and what does it mean to integrate a planning engine, that is the topic of the track A. So the Unified Planning Framework, first of all, is this Python library that I was talking about. It is, first of all, it's not limited to plan generation. I think I already said that one. We wrote it in Python with a focus on usability and expressiveness. So at the moment, what we're capable of representing are classical numerical temporal planning problems, multi-agent, hierarchical task decomposition. We have support for contingent planning with some limitations, with the uncertainty on the initial state. And we are working towards task and motion planning and scheduling. So a more, say, simplified version of temporal planning. So that's what is currently supported by the UPF. You can see all of these at different level of maturity, to be honest, but everything happens publicly on GitHub. So the link here, the github.com/aplan4you, you will see all the code generated by the project. Everything is permissively open source. So you can have a look. You can look around for the documentation. Any feedback is welcome at any point. There is also a live demo here. I don't have the time to show it to you, but you will have the slides after the webinar. So if you want to have a look, you will be able to try it out live in a Python notebook. So now we have this library. This library is primarily concerned about representing and manipulating planning problem. And then it has these interfaces, these operation modes for calling external solvers. So in this picture here, you will see with this syntax here, with one-shot planner, blah, 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 as planner.solve. So this interface here essentially abstracts away some planning engine that is capable of solving this problem kind. And with these solve methods, we are asking it to solve the planning problem. So invoking the planner. Everything happens under the hood. You don't really know, in this example, you don't know exactly which engine has been selected, but we have, of course, primitive for telling exactly which engine you will like. You have the possibilities of running engines in parallel, you have capabilities for supporting, again, different operation modes. Now, I think I already told you what is a TSB. So it's this piece of code that can be reused and that somehow uses directly or indirectly the unified planning framework inside. And it's designed to be integrated into some ICT infrastructure that is dedicated to the use case. So this is more important, of course, for the track B and C, but just to give a little bit of picture of what we're after. So what does it mean to do a planning engine integration? So Alfonso later will give you a little bit more details of the work that we have been doing within the project. From an high-level point of view, the idea is to offer some kind of service through the unified planning framework. So the idea is, do you have some engine, some kind of software, some kind of solver that is capable of tackling some problem related for automated planning? What we are asking in track A is, well, offer yourself, let's say, propose to integrate it within the unified planning framework so that this service can be consumed through the unified planning framework. This will mean that if, unless, let's say, the interface, the current version of the unified planning framework already has the interface for expressing your problem and representing your solution, you will need essentially to add a little bit of code to the unified planning framework for representing what you would like to solve, let's say, and then create the glue code between this Python library that is the unified planning framework and your engine. So that's the two pieces of work. Later, or now, Alfonso, you tell me, I have a small demo of what it means, of what does it mean, let's say, to integrate an engine. It's, again, you can even look at it offline. So it's a piece of Python code that creates a very simple engine that does a random search, but it gives you a little bit of the flavor of what does it mean to do the integration. And important things here. So the interfaces that we want to have within the unified planning framework should be engine independent. So if you want to offer, I don't know, the visualization for a certain kind of plan, or you want to add a new way of preparing a plan, it's totally fine. But what is important for the project is that somebody, wherever in the world, let's say, should be able to create a new engine that serves the same purpose and is not your engine, right? So it needs to maintain this engine agnosticity. So it doesn't want to know which engine is about. And so no direct exposure of internal data structures, these kind of things. Okay, I'm a little bit out of time, but I'm mostly done. I will simply answer a question that is happens sometimes. That is, what does it mean to integrate into this AI for EU platform? So for the project, we have two kinds of integration. The first one is to integrate it as a service. And in particular, inside of this platform that I was talking about, you can visit it in AI4Europe.eu. There is a part that is called experiments. And what you can see there is to execute some small-scale demos and experimentation directly online without installing anything on your machine. And we would like to bring the integrations that are devised within the open calls in this experiment subsystem, so that somebody can show, or at least see, the potential of AI planning directly online. Again, zero cost installation, and you see something running, you can edit a little bit the problem, you can understand how it works. So that's the first kind of integration. The second kind of integration is clearly as a downloadable resource. So the idea will be to allow the user to execute the UPF and the engines that you provide, maybe at its own premises, and so that it can solve larger problems, or it can hack a little bit more with the thing. And final thing, we will add training material, documentation, use case description in the platform itself. Luisa will enter much more into the details. Here I'm simply saying that within the project, we had, at this point, we are towards the end of the project, two types of open calls. And the open call that will close in January is the last open call for the project. We had open call for use cases, in which we had workshops with the winners to elicit additional use cases, and we really saw interesting and diverse, I think is the right word, use cases that were identified in practically any application sector that you can think of. And then the second call, that is the one that is open now, is the open call for innovators. And again, so the track A, that is what we are talking about, we are looking for, in track A, for the planners, so for planning engines. In track B, we look for technology-specific bridges and use cases together. And in track C, we are looking for technology-specific bridges for the use cases that have been identified in the open call for use cases. So that's it for the general overview of the project. I will be very happy to take any question now or later or via the chat. And yes, thank you so much.
And thank you so much, Andrea, for the great overview of the project and the track A. But now, to go more into details of what we really intend with track A and who we are really looking for, I will give the floor to Alfonso.
Hello everyone. Good afternoon. So let me share my screen if I can make it. Not sure I can do it actually. Sort of a problem here, security and privacy.
While Alfonso is trying to share his screen, let me just say that if you have any questions at any point, you just write them in the chat and we will be glad to answer them.
Sorry for this. It's this problem never arised. So that's doesn't allow me to share my screen. Open system, security and privacy, preferences. No, I can't. So can I give you the link? The slides are in Google Drive. Can you share them for me?
Yeah, no problem.
Put it in the chat. Sorry for that. It's the first time that.
Not a problem. Oh. We'll need access.
Okay, what's your email address?
Marina@fsuccess.com.
Okay. I should have it.
Yes. Okay, I will share my screen then. Okay, I think you can see it.
Yeah, thank you very much.
Go ahead. Tell me when to change the slides.
Oh yeah, you can change the slide. Please change. Okay, so I'm going to talk about the work package 4 that concerns the integration of the planning engines in the AI for AI planning for EU platform. And so what we want to do is to integrate with the UP framework a number of planning engines. And the engines that we integrate should be easily usable with an implementation that is transparent to the user and that can expose as many functionalities as possible. There are two modalities of the integration with the UP, what we call the shallow integration and the deep integration. The shallow integration is basically through external files and can be used when the interaction between the planner and the UP is offline, that is before planning or after planning. The interaction online is when we have, for example, interleaved planning and execution, and so the interaction with the UP is tighter. In this case, we have the deep integration that is directly done through data structures. The functionalities of the planning engine should be exposed through the notion of the operation modes that Andrea illustrated before. Please, next slide. Okay, so in the work package 4, we have different planning approaches. This according to the project proposal, but possible additional approaches can be integrated through the open calls together with the planners. So the 6 approaches that corresponds to different tasks of the project are the following ones. Classical planning that involves the University of Basel and the University of Brescia, and the leader here is the University of Basel. Numeric planning that involves only the University of Brescia. Temporal planning that involves FBK, University of Brescia, CNRs, and the University of Örebro, and the leader here is FBK. Multi-agent planning that involves University of Sapienza, and refinement planning or HTN planning that involves CNRs, and the combined task and motion planning that involves the University of Örebro plus CNRs, and the leader here is the University of Örebro. Next slide, please. So I'm going to review very briefly each of these tasks of planning approaches to tell you what are the main planners that we have already integrated through with the work of the partners of the project. So for the classical planning integration, we have fast downward with the following operation modes: one-shot optimal, satisficing planning, anytime planning, and also grounding. It is instantiating all the actions through a deep integration with the UP. LPG, that supports operation modes of satisficing planning, anytime planning, and plan repair. And Piper plan through a deep integration with the UP that supports the operation modes satisficing planning and grounding. Next, please. Numeric planning integration, we have 2 planners from the University of Brescia, LPG and ENHSP, that are in some sense complementary. LPG supports numerical planning through linear expression in conditions and in effects, while ENHSP supports also non-linear expressions in conditions and effects. For the operation modes, we have one-shot planning, satisficing, anytime planning, and plan repair for LPG, while for ENHSP, we have one-shot planning, satisficing, and optimal, plus anytime planning. Next, please. For temporal planning, we have triggered 3 planners. Tamer from FBK that supports a fragment of the animal language with the intermediate conditions and effects, some numbers, some features with the numbers and the timed goals, but it does not support the HTN fragment of animal. And the operation modes here are one-shot planning and a temporal plan validation. The second planner is areas from the CNRs that supports what Tamer does not support, that is the HTN fragment of animal plus time, so hierarchies with the time. Then there is also LPG that supports PDDL 2.2, and this is from the university operation. Next slide, please. For multi-agent planning, we have the University of Rome Sapienza, who is working on this task. And we have 2 approaches, the centralized approach to multi-agent planning and the decentralized approach of FMAP, which is a planner that is external from the partners of our project and has been developed in Spain from the University of Valencia, if I remember correctly, and we have integrated it in the platform. In order to do this integration, we had to extend the UP interface in order to take into account that there are multiple agents that cooperate to solve the problem. Next slide, please. For the refinement planning task, the leader here is CNRs, and basically we have 1 planner Aries developed by Atlas. And this is a hierarchical planner with temporal features. The focus here is on optimality, so generating optimal plans, and the operation modes are one-shot, optimal, and also anytime. The system supports HDDL, that is a standard language for HTN planning that is built on top of PDDL. Next one, please. And the final task is for planning for task and for motion that is developed at the University of Orebro. In particular, we are integrating Spider Plan, and the integration is done through a Python library that converts the UP problem of task and motion planning to the IDDL language that then is sent to the Spider Plan server. And the operation mode here is a one-shot planning. Next, please. Okay, so this is the very quick overview of the planning approaches that we have already integrated, and we are finishing this work. It's not really completed yet, but the end of this work package is end of March. So we expect to have all the technology that I have mentioned completely integrated by the end of March. In addition to the integration of the planners and the code and the integration with the UP, it is also important to develop a repository of test cases that we are doing. And these test cases, this repository is organized as follows. We have 1 section for each planning approach, so for each task that I have described, and each section has 2 subsections. The subsection where we have the formulation of the problem that can be done through an external file, for example, PDDL file, or directly in the UP framework. And in this formulation, we try in each of these formulation, we try to stress one particular aspect of the planner and or of the planning approach. for example, stressing how the planner handles conditional effects, or how it handles non-linear expressions in numerical planning, whether it handles them and how it handles them, and so on. The other subsection is the section where we have the files for running the planners, using the problem formulations that we have in the other section under different operating modes, because a planner can support different operating modes. Next slide, please. So I guess I'm going to skip this about our meeting. Next one, please. So, so what do we expect in the proposal of a new planning engine with respect to what I have said in the last 5 minutes, 10 minutes? So we want to see an indication of which kind of operation mode the engine supports. It could be more than one operation mode. Which kind of integration will be done, whether an external through external files, or there is some sort of commitment of doing a more deep integration. And if the planner fits some of the current planning approaches that I have already indicated, that's fine. You can integrate another planner for task and motion planning or for multi-agent planning, or whether it does not fit these planning approaches, and it could also be okay. In this case, we expect also an integration of some work on collaboration with the UP, with the development of the UP, to introduce the necessary features to support the new planning approach and the new planners. If the proposal will be accepted, there will be some meetings in which we require periodically an update, status update about the progress that has been done for the integration, for the definition of the use cases, and also all the possible issues concerning the interface with the UP. If something is missing in the UP, we have to integrate it, and we have to extend the UP in order to accommodate what the feature that is missing in the language. Okay, next slide, please. Unless this is the last one. I think this is the last one, probably.
Yeah, it's the last one.
So I think there was a slide for a demo. I don't know if Andrea is going to give us a demonstration, or
if we have time, Marina, I can give a very short demo. It will take like 5 minutes.
Yeah, I think it's
no,
good
we can
to have
skip.
it. I will. No, I think it's good. If you are up to it, I will stop sharing now.
Yep. So let me reshare my screen then. And thanks, Alfonso, by the way.
Oh, yeah, of course. Thanks, Alfonso, for the explanation.
sorry for the problem with my sharing.
Everything was solved by the end, so don't worry.
Okay, so you can hear me, hopefully.
Yes.
Okay, can you also see the thing scrolling here?
Yes.
Oh, we'll make it a little bit bigger for you. So I will not spend too much time. You can access this one. I will post the link to the chat as well. Actually, I can do it right now, so you can have it. Copy link. Yes. But I sent only to us the panelists. Okay, can you reshare it, Marina, to everybody, because I can only chat to hosts and panelists, but that's okay. So otherwise, you will have the link in the slides anyway. So
I will.
So this is an interactive demo. Things are actually running, as you will see. So with this command here, if you're familiar with Python, is an installation of a Python package. So I'm installing the unified planning, that is the library that I was talking about, and also Alfonso was hinting at. And in this example, we are defining a very, very simple planning engine, a planning engine that is designed to solve a planning problem in a very stupid way by randomly search in the search space for classical planning. But what the important point here is, what does it mean to do an integration, right? So that's the meaning behind this demo. So in order to create an engine, what you have to do is to create a Python class. I call it my solver implementation here. I hope you can see my mouse, but here anyway. That inherits from the engine class and that implements the operation mode that is called one-shot planner. So that's what it means to do this inheritance. The implementation itself, it's not very important. So here you can do whatever is relevant for the engine that you would like to bring to the library. So, you know, contingent planner does something. I read before from Ronnie, learning, something that is based on planning and learning can do something completely different, right? But the point is that this is the piece of interface that you have to respect. You have to give a name to your solver. This is an interesting feature. So you need to define, so to create this method that tells me whether you support a certain problem kind. So problem kind is a class, is a Python class defined by the Unified Planning Framework. For those who are familiar with PDDL, this is conceptually similar to the requirements annotation that you have at the beginning of a planning problem. It tells you essentially what are the features, the syntactical feature that you are using in your planning problem. And it is actually automatically computed in our case. So the user does not need to tell the problem kind, you know, manually. It is automatically derived by the feature that is using. So for example, you know, it's using a hierarchy of types. This is a numeric planning it supports numeric planning problems with both continuous and discrete numbers. It might have existential conditions and so on and so forth. So we have a set, let's say, of things that can appear inside of this problem kind, and the job of this method is to tell me whether I can use this engine on a problem that is of a certain kind. So the answer is a yes, no, and in this case we are replying by this subsumption, let's say, operator. The logic here can be engine dependent, right? Maybe you support a problem but not another one. Well, you say that you are a one-shot planner, clearly, because that's the operation mode that you would like to solve. And each operation modes define one or more methods that you have to implement. And in this case, this is the signature of the solve method that we have to support. The details are not super important for the demo, but essentially you get a problem and you would like to have as a result a plan generation result. That is a class that tells you whether the problem is solvable, unsolvable, if you encountered an error in solving it, if it is solvable, it also contains a plan, and so on. So it's let's say a result object that you can express. The implementation internally, we are, if you are curious, what I'm doing is I'm grounding the problem, and by using the UP. So I'm asking the UP, please ground the problem for me, getting the list of actions, and then essentially randomly search in the search space. I'm assuming a numeric or classical problem, let's say, and at each step I'm checking the validity by means of a validator. So, but again, the body of this method is really the job of the integration, right? So here you should somehow transform this problem representation into data structure or file formats or something that is understandable by your engine, invoke your engine, either as Alfonso was saying, right? Either via file, so by invoking a sub-process, or via as a library, so by what Alfonso called the deep integration. And then get back the result and then construct a result object out of it. Here I'm writing everything in Python just for the sake of the demo. Then once you finished essentially the implementation of this class, you are almost done, right? You declared everything that needs to be that is needed for the UP to call your engine. The only thing that you have to do is to register it. We have a set of engines that are automatically registered in the UP so that the user doesn't need to do this step manually. For an external engine, until it is stable, you can do it manually. That is like this one. So you add an engine. I'm calling it YOLO Planner, and I'm indicating the name of the package, so the name of the file where the class is defined and the name of the class that I used for my engine. And this is enough. So the UP will automatically look for this class, understand which are the mixins that it inherits from, and add it to the set of engine that can be used. At this point, you can use it together with any other engine. So I forgot to execute some of these cells. So this is the implementation of the engine. What I forget in the middle. Ah, yes. Okay. Oops. Okay. So there is a problem. Ah, because I typed 0 for some reasons. Oops. Sorry for that. I think I edited it without wanting to. Okay. Good. So this is executed. So this is the registration of the thing. And then finally, you can create a problem. So this is simply some code that creates a simple problem. I can even, if you want, like print the problem. So have a look. So it contains a set of fluents, some actions, some objects, blah, blah, blah. So it's a planning problem, a very stupid one, actually. And then you can try out the engine. So what you do is to ask for the one-shot planner. And in this case, you are explicitly asking for YOLO planner. So exactly this engine. And you are invoking the operation mode as so. And then I'm printing the plan, basically, so doing nothing particularly fancy. Right, so yes, for this super stupid problem, even this very simple planner is able to find a solution. But I hope this can give you a little bit of an idea of practically what does it mean to do an integration. And of course, if you have any question, I will be very happy to answer. And again, I will give you the link of the demo. I don't know if Marina already shared it or not.
Thank you, Andrea. I didn't reshare because your link seems to be broken. I clicked on it and I couldn't access for some reason. So you have some time while Luisa is talking to figure that out and to post the link on the chat.
Good.
Thank you for this demo. Now, Luisa, please walk us through on how to apply to this open call.
Okay, so thank you, Marina. I'm going to share my screen. Just one moment. So can you see my screen?
Yes, perfect.
Okay. So good afternoon, everyone, and thank you for having me today. So I'm going to talk about a bit about how to apply on the open call. And I'm Luisa. I'm from App Success. So App Success is based in Ireland. Is a leading platform that connects different companies, different organizations, and also people around the world with investors and governments and universities and research centers that are interested in developing different solutions. So in AI Plan for You, we are partners and we are responsible for managing the open call. I work with Marina. She's responsible for the online dissemination of the project, and I'm responsible here for the open calls. So the open call, in a nutshell, as mentioned before, today we are talking about the track A. This open call encompasses different tracks, 3 different tracks. But today the focus in track A that aims to engage different innovators and organizations to come on board and to develop new planning engines. But everything that I'm going to talk here to talk to you here today is valid for the other tracks. Today I'm going to focus on track A, but you can consider also that the process is the same for the other tracks. So here it's just to have a clear view that we are in this open call 2 for innovators. We are addressing the 3 tracks, track A, B, and C. And track A is specifically to select planners to help us to developing the planning engines, and the other tracks are more related on related to the development of the TSBs, the technology specific bridges. So how to apply? So there are some steps here that we have developed a framework that to make this process easier to both the consortium partners and both the applicants. So here you will start by a submission in the F6S platform. So you will fill a form, and I'm going into details in the next slides about it. Then we will filter the applications because there are some rules to follow regarding the eligibility of the applications. And then if everything is okay, this proposal will advance to the evaluation that consists of different partners coming on board to evaluate and to analyze your proposals. So if selected, you will sign a sub-grant agreement with the consortium, and then you start to implement your proposals. So I'm going into details around each stage. So then we can probably you have more questions on that. So first, the open call budget for track A, we are going to fund 4 projects with 60,000 euros, and organizations and individuals who will be engaged with the projects will be on board AI Plan for You for 7 months. So regarding the eligibility, the target applicants are single organizations. When I say organizations, with valid VAT, of course, a registered company, and different companies, for example, medium and large enterprises, SMEs, research institutes, universities, different foundations, different organizations, any type of organizations are eligible, and also individuals, researchers, professionals, experts are welcome and eligible in this project. So applicants from Europe and associated countries, when it means that the companies must be registered in Europe or in any associated country, and individuals not necessarily needs to be an European citizen, but they need to have a resident permission in any of the countries. So in the documents you find the links to the list of countries that are eligible. So and the proposals can be in any context, sector. Although the project is developing the solutions in certain in context, we are accepting different proposals from any sector, because we believe that this will reach the library of AI planning solutions. So even context independent solutions are eligible here for track A. So how to start to apply? You need to go to the websites. That is the easiest way to start filling a form. But before submitting, I recommend some items here, some steps that you should pay attention. So go to the website and click on the apply now, and then you go to the web page of the open call, and there you will find summarized information about the call. So the key information about the call, for example, the list, the type of applicant lists, the budget, and then also the details of the tracks. So for track A, to apply to track A, please click on the track A option, and there you will find information about this track. So here you'll find what is this track about, what are you looking for in this track, so the funding and the deadline and how to apply. But here I would like to highlight that there are on the bottom of the page, there are 3 different documents that you should click on that and read before submitting, because in the open call context you will find a summarized overview of the project and the call, and some important dates and links for the pages of the project. But the guideline for applicants, the guide for applicants, I believe that is the most important document here, because there you find all the details about the call, about the open call rules. For example, the eligibility criteria, evaluation criteria, and the list and the links for the eligible countries, and the different information about the payment schema, for example, the deadlines, the timeline of the call. So you find everything there. So I fully recommend that before starting filling out the form to submit, take some time to read this document, just to check if you are eligible, if it's a good opportunity for your company, and then you can advance. And here, the other link, you will find the template to track A, because to apply, you need to fill out a document, a Word document, with your proposal, to describe your proposal. And I fully recommend that you take some time to write this, because evaluators will base their analysis on the description of your project according to this document. So here's just a very brief summary of this document. So it's not a very big text that you need to put there, but you need to add key information in order to describe your project. And as I mentioned, the evaluators will base their analysis on your description. So you just need to write an introduction and describing the planning engine, with some information about the integration, the demonstrator, information about the license and the intellectual property, the profile of your team, and a work plan according to the structure of the sprints that in the guide for applicants we also mention what you are going to do if you are selected after all this process of selection. So try to read the document, the guide for applicants, and then you move to this template in order to describe your proposal accordingly. So after reading the guidelines and writing your proposal, now you are prepared to apply. So on the bottom of the page, you find a button. You see a button, and then click on this button, and you will be guided to the F6S platform in order to fill a form. So the form is very simple. It's not something that will take a lot of time. So, but take into attention to choose the options accordingly. For example, here the first question is, what track are you applying? So just click on track A and try to fill out all the questions. For example, relevant questions about the proposal title, the proposal summary, and do not forget to upload the description of your proposal according to the template. So you find the link in that page, in the open call page that I have mentioned before, but you can also find the link to the documents, to the template here on the form. So I'm highlighting that because we receive a lot of applications with another document there that is not according to the template. So it's crucial for your proposal to be evaluated. That's why I'm highlighting a lot this point, because without this document, we cannot see, we cannot go into details, and we cannot evaluate your proposal. So after that, after you submitted your proposal, you uploaded the documents, and you filled out the form, and if the eligibility, according to the eligibility check, your proposal can advance to the evaluation stage. So the proposals will be evaluated by the consortium partners that are experts in AI planning, and they will basically check the challenge fit, the technology innovation, the impact of your proposal, and the work plan. So you can see all the evaluation is detailed in the guide for applicants. If you would like to go into details to see how do we score the proposals and how we are going to evaluate them, you can check there. So if it's okay, we move to the online interviews, but here this step is optional. Only if the evaluator has some questions, that's if something is not clear for him or her, they will invite you for an online interview. But usually they check your proposal, and then we move to the consensus meeting, and all the evaluators will come together in order to achieve a final consensus about who is going to be, we will sign the subgrant agreement and start implementing the projects. So this stage is it's the legal phase of the call. So FBK, that are also the coordinators, will be in charge of that. So here is just that legal procedures that involves the subgrant agreement signatures, the double check of documents, and this phase is very it's very simple. It lasts around 1 month, and of course during this phase FBK and of course F6S will check if everything is okay, everything is complying with the open call rules established by the European Commission, and then you'll be ready to start working on the implementation phase of the project. Just here is just a summary. It involves the sprint and demo system. The sprints, as you can see in the picture, is divided into 3 stages of 2 months, and 1 month, the last month, will be the demo phase. So during this period, the consortium partner will support you on the development of your projects and on the implementation phase. The payments are based on the work accomplished and achievement of objectives. So during this phase, you have to write some reports after each sprint, and these reports will be evaluated by the consortium partners, and the payment will be done accordingly. And the last, I think, is the 7th month, the last month of the program. It will be dedicated to the demo phase. So you will be able to go through the demo where the projects and the SMEs and the individuals will be invited to pilot and validate the solutions. It's a testing phase, let's say. So here is just a very brief summary of what you can expect if the proposal is selected, but you can find more details in the guide for applicants. So here's just an indicative deadline. The call will close by the end of this month. So during the month of February, we will evaluate the proposals, and by the end of February, we will announce the selected proposals. The signature of the subgrant agreement will take around 1 month, but it will take place in March. And the demo, the sprints and demo, and the implementation of the project will last until October of 2023. Just here to wrap up, just with some important information that I have already mentioned, but I will repeat here. So first, access the project website, the open call page, In the open call page, you find all the instructions to apply. Read the guideline for applicants, prepare your proposals according to the template available. It's a very important step here. Click on the button available to fill out the form on F6S platform. Fill the requested information and do not forget to upload the proposal project and submit by the 1st of January. So here is just to remember that the target applicants are organizations, single organizations with a valid VAT, of course, and individuals. Eligible countries are EU members and associated country. As I mentioned, you find the links to check the list of eligible countries in the guide for applicants. And the number of projects that we are going to select are 4 projects, and the funding is 60,000 euros. So here, just to remember that we also, during this period, we also answer to some questions by email. Don't hesitate to reach out to us. We'll be glad to answer to your questions. So, and of course, you can also check the information on the website. So that's it from my side. And if you have any questions, I'll be glad to answer. Thank you.
Thank you, Luisa, for your presentation and guides on how to apply to this open call. We just have one question in the chat that is about what you just explained. So someone, Amandine, is asking if 2 individuals together are eligible.
Oh, yes. Yeah, no, not 2 individuals together. So in it's not about track A, that's why I didn't mention the consortium, but in track B, we will accept an SME and a use case owner that is another SMEs, but 2 SMEs, not 2 individuals, unfortunately.
Yeah, but I think what was meant was if 2 individual people can apply to track A. The answer is still no. One of you needs to take the lead.
Yes.
Can be 2 people working on it, but one needs to be the responsible person applying on the F6S platform. Although then you can, of course, both of you work on the proposal or on the project. I think it was this that the person meant. Okay, so if there are no more questions, I don't know. Can I just quickly share my screen, Luisa?
Sure.
If you have any more questions, please, it's the time now to ask them on the chat. If not, we are a bit over time already, so I will just remind you again of the webinar we have next week, 1 week from today. Today's one was focused on track A, but next week we will have another webinar focused on track B and C, where we will also explain the particularities of these tracks and present some use cases that are engaged in track C. So here, next Wednesday, the same time, 2:30 CET. And if there are no more questions, oh, there is something. There is a question here. How early stage companies or startups that can apply?
Oh, yes. When you mean early stage companies or startups are non-registered or non-incorporated companies, I don't know if I understood that. Because
I don't know. The person just wrote how early stage companies or startups can apply.
Yes, if this company is already incorporated and has a valid VAT, the companies are eligible for sure. No-incorporated companies are not eligible because we will need to refer the VAT number in the contract, in the sub-grantee agreement, so they are not eligible. But if the company is incorporated and has a valid VAT, they are eligible.
Registered, but little to no traction.
Yes, they are eligible. If they are registered, they are eligible. Although they are in the early stages, we can consider as an eligible company.
Okay, so I guess we answered all the questions. I don't see any more questions. Okay, so, you know, the instructions to apply, just go to the AI plan for you/project.eu, and there you will find the link to the open call too, where you can find all the instructions as Luisa mentioned. If you want to contact us or you have further questions, please please contact us via email to aiplan4u_support@fbk.eu. And soon, maybe tomorrow already, we will have the replay of the webinar on our YouTube channel, youtube.com/@aiplan4u. So I think we can wrap up this webinar, and thank you all for your presence here today. Thank you, Luisa, Alfonso, Andrea, and thank you to all the people that were present here with us today.
Thank you, Marina, and thank you all for being here. Bye.
Bye, thank you.